All right, so we're going to start talking about section 1.1 and 1.2. We'll be covering pretty much just rectangular coordinate system, the real number system. We're going to talk a little bit about slope-intercept form and domain and range. Those are the main topics we're going to cover in these two sections. So just to begin with, I want to be sure you understand a real number system and what that just means. All right, so when we talk about a real number system, we begin with natural numbers. And natural numbers, these braces that I use are just denote a set, all right? So natural numbers are just positive whole numbers, and they go on infinitely. Okay, that's what the dot, dot, dot means, that they will go on positively to infinity. And they're just whole numbers, positive whole numbers. All right, then we have whole numbers. And whole numbers are the same. They include all natural numbers, but they also include 0. So they are positive whole numbers, including 0. Then we have integers. We talk about integers quite a bit when we talk about domains, which we'll discuss later. So integers are positive and negative whole numbers, including 0. So they go all the way. They go infinitely to the positive, and they go infinitely to the negative, but they're whole numbers, not fractions or decimals, including 0. So notice that natural numbers fall within whole numbers, and both natural and whole fall within integers. But integers do not fall just in natural. They do have natural numbers in them, but integers also have negative numbers, and the natural do not. All right, so these continue on, and so now we have rational numbers, and a rational number is a number that terminates or ends, or it has a repeating pattern. So this would include fractions and decimals. So the main terminology is it terminates or it has a pattern. All right, so an example might be if we have 2/4, right, that reduces down to 1/2, which reduces down to 0.5. So that's what I mean when I say it terminates, it ends. But we might have something like 1/3, and 1/3 is 0.33, and it just goes on infinitely. So we call that a repeating. So that has a pattern. Since it has a pattern, that also is a rational number. Now we can also, and then rational numbers also include integers, whole numbers, and natural numbers. So if a number is not rational, then that means it can be irrational. And irrational numbers are non-terminating decimals, which means they're just a decimal that doesn't end. So they're non-terminating. So like pi. Pi would be a non-terminating decimal because it goes on infinitely. If you put in your calculator square root of 2 or square root of 7, those are decimals that are just going to go on and on and on and never end. So those are called irrational numbers. So when I work with irrational numbers, I always have to round them because the decimal goes on and on. So this is always going to give you an approximate answer when you have an answer that's irrational, because you have to round it. And then when I have a rational and it ends exactly, not necessarily with the pattern, but if I have a rational number that is 0.5 or 7, or that is infinite and it ends, so that's an exact answer. So many times with rational numbers, if it's not a pattern, then you're going to get an exact answer. Irrational, it's always going to be an approximation because you have to round it. Okay, so all of these make up the real number system. So when we talk about all real numbers, it's everything on a number line. And number lines are pretty important because there's so much that is involved in number lines that we really don't think about. But all rational and even irrational numbers fall on a number line. Like there's 1.293578. That's on a number line. Now we can't find it exactly on the number line because the number goes on forever, but we know it falls between 1 and 2, right? So if I have a number line and I have 1, 2, 1.376829, it's going to fall in between here, and I can estimate it's going to be before 1.5. but I don't know exactly where it is because that number goes on forever. So really these numbers in here, these irrational numbers, are infinite, which is kind of weird to think about, right? Because you feel like, well, it ends at 2. Well, I can have 1.99876 and go on forever, and it will never get to 2, but it will get really, really close to 2. And those are things that we're going to talk about in this class. So this is just the real number system. I want you to recognize what that means. Eventually, in the course, we're going to talk about complex numbers, which are dealing with an imaginary number I, and that's a negative square root. So that's kind of a whole different type of number system. And so it's not in the real number system. But all the numbers that you work with now that you probably know most about fall within this. All right, so the other thing I wanted to talk to you about is just the rectangular coordinate system. So, because we do quite a bit of graphing. So on the rectangular coordinate system, here is quadrant 1, quadrant 2, 3, and 4. And there are different types of graphing systems, coordinate systems. You have polar graphs, just different things that, depending on what kind of mathematics you're doing. So there are more than one type of graphing systems. So if I wanted to know what quadrant ordered pair 1, 2 fell in. So again, remember, this is your x-axis, this is your y. These are your positive numbers, positive. These are your negative, these are your negative. So 1, 2 is going to go over 1, up 2. It's going to fall in quadrant 1. So where would 2, negative 3 fall? Well, we do a positive 2, so we go 2 and the negative 3. It's going to fall in quadrant 4. All right. What about 0, 0? 0, 0 is right here. And there's a name for that, and that's called the origin. Now, I might ask you, what quadrant does 2, 0 fall in? Well, 2, 0 is right here, and that is on the x-axis. So if it's on an axis, that's where it falls. It doesn't fall in a quadrant. So what quadrant does it fall in? None, because it's on an axis. It falls on an axis, all right? Lots of students would put 1 and 4, but it's on the axis. That's where it falls, all right? Not in a quadrant. All right, so now we're going to talk about, that's all of section 1.1 that we're really going to review. All right, so we're going to talk a little bit now on 1.2. This is pretty much section 1.2. And we're going to talk, one thing we use a lot in this class is interval notation. We use it all the time. We write most of our answers in interval notation. So it's pretty simple once you understand what it is. But I want to begin with what's called set builder, because sometimes I want you to be able to read what set builder means. I'm not going to ask you to write anything in set builder, although I could, but I'm not going to do that because we really focus right now on interval. But I want you to understand what set builder is. All right, so this would be an example of a set builder. Okay, it's within a set. And this is saying for all of x, okay, for all of x, where x is greater than negative 2. All right, so for all of x, where x is greater than negative 2. So that's what set builder means. So if I were to graph this on a number line, remember we always read from the variable. So we're always going to read from this. So this is just saying for all of x, whatever I put in for x, all right? So I don't have to worry about that when I'm looking at the graph. X is greater than negative 2. So we'll always read from this, because if I say x is greater than negative 2, this is probably how most of you learned to do this, greater than negative 2, with an open circle, closed circle. If it doesn't have an equal sign, then it's an open circle, which means negative 2 is not true. If I put a negative 2 in there, negative 2 is not greater than negative 2. That's why it's an open circle. It's not a solution. But anything from here to the right is. Right, so any number, even these numbers I pick in between here, negative 1.99, is negative 1.99 bigger than negative 2? Yeah, it is. So that just means there's infinite solutions, because this goes on infinitely to the positive side. Now, if I want to write that in interval form, okay, here's what we need to know about interval form. If I use brackets, that means it's the equal to. It means I have an equal to below this. That means it's a solution. Okay, it's part of the solution. If I use parentheses, that means it's not equal to. Okay, and it's not a solution. So right here, if I say x is greater than -2, would you agree that -2 is not greater than -2? So this is not a solution, which is why I use an open circle. So now what we're going to do is just pretty much replace the open and closed circles with these. All right. This was the original closed circle. This was the original open circle. So let's do it in interval notation. So would you agree? I'm going to start, when we do interval notation, we always go left to right. So we're going to start here on the left side, and we're going to start at -2. I'll just put it here so you know what we're doing. Okay, so we're going to start at -2, and because it's not equal to, because it doesn't have an equal to, I use a parenthesis. So we go from -2, and where does this graph go? Well, it doesn't ever end. It goes on forever, and that's infinite. So that's what infinity is. So it goes on to positive infinity. Now, can you ever equal infinity? You cannot, right? Because it just keeps going on and on and on, so it never stops. So anytime you use an infinity, you always are going to have a parenthesis on it. All right, so let's say I give you this one in set builder. For all x where, let's say, trying to think when up here. Okay, so let's do this. All right, so for all of x where x is greater than -3, but less than -5. So solutions where x are greater than 3, but less than or equal to 5. So let's, maybe what, and you don't have to do these number lines. Sometimes it just helps to visualize it if you're a real visual learner. Sometimes it's nice to just see it like this. So remember, always read from the variable or you're going to do it backwards. If I say -3 is less than x, I feel like I should go to the left side because I said less than. But really what you should graph is x is greater than -3. So that's why you always read from the variable. So x is greater than -3. All right, so does it have a parenthesis or a bracket? Well, because it doesn't have an equal sign like this one, it's going to be a parenthesis. So we have a parenthesis at -3, greater than, goes to the right. Okay, also then, any solutions where x is less than or equal to 5. So because this has an equal to, we're going to use a bracket, and we're going to say less than 5. So all solutions that fall between these two. So what are those solutions written in interval notation? Well, that's going to be written as start from the left. So from -3 with a parenthesis to 5 with a bracket. All right, let's try and do one. Well, let me write one more out because I think this one you need to probably see x. So for all of x where, let's say x is less than or equal to a -1. All right, so if you want to look at the graph of it, x is less than or equal to -1. So less than or equal to is going to be a bracket. Less than or goes to the left. All right, so if I want to put that in interval notation, remember we always start from the left side. So we're looking over here on the left side. Well, where does this go? This goes to -infinity. So that's where I begin this graph. So I go from -infinity and I end here. So this begins again with parentheses because it's infinity, -infinity over here, and we end at a -1. So comma, -1 with a bracket. So solutions are anything that fall between these two, including -1. All right, so that's interval notation, and we will be doing a lot of work with interval notation, so we'll talk about that more as we move on. Okay, so let's see. So let's talk about domain and range. I might just get a new sheet paper here. All right, so domain and range. So we're going to be talking about functions in just a second, but functions can be are made up with what are called relations. And what a relation is it's just a set of ordered pairs. So here's your braces that designate a set. And so, you know, whatever you want to, let's see, let's just put some ordered pairs in here. Let's do, okay, so let's go with this. So here's a relation, just a set of ordered pairs. All right, so I'm going to ask you a couple questions. First of all, I want to know, what is the domain of that? What is the range of that? And is it a function? So those are the three things I'm going to ask you to be able to tell me. So when I look at this, here's something that's super important. So I'm going to start, not that all of it's not important, but we use domain a lot. So what the domain is it's the X values. All right, we have to remember it's the X values on our graphs. Or if we only see the ordered pairs, we may not see the graph. So if I asked you, okay, well, what's the domain then? So what I'm going to do is I'm going to put it in a set, because we're designating a set, it's a domain, and we have whatever our X values. Remember, these are X. The ordered pairs are written as XY. So 1, -2, 0, and -3. That's your domain. Now, if a number was written twice, maybe I had another one, maybe this was a 1, I don't write it twice when I write it in this set. I just write it one time. And that kind of, I'll show you that right here. So what is the range? Well, the range then is dealing with your Y values. So when I ask about the range, I only want to know about the Y values. I don't care what the X values are, just the Y values. So what is the range of this relation? So here we look at the Y value. So we have a 2, 5, 0, and now I have 2 zeros, but even though I have 2 of them, I'm only going to write it one time. You only write it one time in your set. Now, is this a function? So functions, in order for something to be a function, it has to have a correspondence, a one-to-one correspondence. All right, and so for every value of X, there's a value of Y. And one-to-one means that these X values can never be the same if it's a function. They will not be the same. And that's really that's all you have to know is, are there any of the X value numbers the same? If they are, it's not a function. Now, that has nothing to do with the range. Later on, we'll be talking about inverses, and then we'll include the range. But right now, with just functions, so if I look at this, look at my X values, they're all different, right? I can even look at my domain, but look here, they're all different. So yes, this would be a function. Sometimes you'll be given the information just maybe in a table. So maybe we'll have a table. All right, so let's say we have something like that. So what is the domain? Well, the domain is going to be your X values. So we have 1, 0, and then we have another one, but I only write it one time. The range are your Y values. So 2, 6, and you don't necessarily have to write them in order. You don't have to. It's nice sometimes when it is written in order, but you're not expected to do that. All right, it doesn't have to be. So is this a function? Well, look at your X values. Look at your X values. Notice your X values, there's a 1 and there's a 1. So I have the same X value. So that means no, it's not a function because it has the same X value. All right, there's something else that's called mapping. So I'm just going to do it quick. So this is your domain and this is your range. All right, so it might have something like this. And so I have the arrows pointing across. This is called a mapping. So really what a mapping is it's just taking one number to another, mapping it to another. But what that really is an ordered pair. All right, so this would be 1, 4. And you don't have to write the ordered pairs. I just want you to recognize that's what it means. So if I look at this, are all my X values different? Yes. So is that a function? Yes. Because all of these are different. But what if I have something like this? Here's your domain. Leave myself a lot of room there. Let's say we have something like this, 3. All right, so let's say this goes here, this maps here, and this maps here. So you can probably look at that and see it, but I'm going to write out the ordered pairs just so you see what I'm talking about. So 3 map to 2, 3 also map to 4, and 5 map to 6. So is that a function? No, because my X values are the same right here. So that is not a function. Now it doesn't matter what my Y values are. So for example, I could do this mapping. Okay, so let's say I have this. That would be ordered pair 1, 5. Oops, sorry. That would be ordered pair 1, 5, 2, 5, and 3, 5. So is it a function? Yes, because these are only used one time. Doesn't matter that a 5 is used 3 times. It doesn't matter what the range is, even though they're the same. The function is found by looking at the x values. So that would be a function. All right, so sometimes we need to determine if something is a function just by looking at a graph, and we don't have these ordered pairs or tables or anything to look at. So when we have to look at a graph, what we use is called a vertical line test. And it's super simple if you understand what the vertical line test is. So I can give you this graph. Let's use somewhat of a circle. And I want to know, is that a function? That's what I would ask you, just giving you the graph. Is that a function? Well, you can't really find all these ordered pairs, so that's why we have the vertical line test. What it means is I draw a line vertically anywhere on that graph. And if it goes through that graph more than one time, then that is not a function. All right. So because do you notice here, this x value, this might be -1, 1. This would be -1, -1. So the x value is the same. That's what that creates when your line goes through 2 points or more. So what about this one? Let's say we have a parabola, which is a quadratic and x squared. We're going to work a lot with those. Okay, let's say we have that. Well, look at the vertical line test. Kind of think it through. See, anywhere I draw a vertical line through there, it just goes through at one time, right? So yes, that would be a function. Sometimes we aren't given, we'll have a graph like maybe this. Let's see here. Let's say we have that graph. Oh, I guess you can't see that. Let me fix this. There we go. So would that be a function? It would, because anywhere I draw a vertical line through it, it goes through only one time. So yes. Okay, what about this? What about that graph? That's kind of an S for stringer. Yeah. Anyway, yep, draw a vertical line. Goes through it 3 times. So no, that's not going to be a function. And sometimes you might just have, what about just a kind of a weird, something like this. Is that going to be a function? Gosh dang, sorry. Can't. Is that going to be a function? Maybe where I draw a vertical line, it's going to go through only one time. So yes. And that's because of the vertical line test. All right. So let's think about writing a domain. I'll just go on the back of this page. Let's write a domain and range with a graph. So let's say I have, bear with me because I'm not very good here. Okay. Maybe I'll try and get this to work right here. All right, so let's say we have this graph. I know it's not great. It's kind of an oval. I'm not sure what shape we would call that. But anyway, it doesn't matter. What I want to know, first of all, is that a function? Do the vertical line test? No, it's not, right? Because anywhere I draw a vertical line, it goes through more than one time. All right, so tell me, what is the domain of this? Well, the domain goes from here to here. That's where our graph on the x values goes. Starts here, it begins and ends. So where does it, we always go from left to right. So where does it begin? 1, 2, -3. And if it's a solid line, that means you use a bracket. All right, so we have a solid line. So we go from -3 and then it ends over here at +3 with a bracket because it's a solid line. All right, so when we do the range, we always go from bottom to top. So we're going to start down here at -2, and it's a solid line, so it's -2, and it's going to go up here. That's the highest of the graph, which is at a +2, solid line. All right, what about this one? So what if we want to find the domain and range? Let's just go with a parabola, kind of like we were talking about here a second ago. Let's go with this parabola. All right, so you notice when we have these arrows, that means they just continue on infinitely, right? So when this is going on infinitely this way, my x values, if I were are going the same way. When I go this way, my graph is going up, 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 up. My x values are getting larger, larger, larger. So when it has the arrows, that means this is going on infinitely. So for your domain, okay, that's going to start clear over here at infinity because it's going forever. So it goes from negative infinity. Remember, domain is the x values. And as this keeps going up, these x values keep going to positive infinity. All right. And okay, I was going to tell you something, but I'll hold that till later. Give you too much information. All right. So on the range, we're going to start at the bottom. Well, where does the graph start? When what? Well, y is 0 right here, right? This is when y is 0. So, and it's a solid line. So the range goes from 0, and then as these continue to go up, my y values continue to go up. So it goes on to positive infinity with the parenthesis. So if you just kind of think about it, so the range goes from bottom to top. This is the lowest point at 0. All right, so now I want to talk about function notation. So this is kind of how you've seen graphs, these linear lines, right? That means it's a straight line. When this is a power of 1, that's just going to be linear, which is a straight line. Now, if I asked you to write that in function notation, all I want you to do, I'll put that here so you know what I'm doing, is I just want you to write it with an f of x or a g of x. Doesn't matter what the variable is. So if I wrote this in function notation and I used f of x, that would be function notation. Now notice all I did was exchange y for f of x. So this is another super important thing to remember, that y and f of x mean the same thing. So y equals f of x. So I could replace this with a y anytime, and I can replace this with an f of x or a g of x or a t of x. This letter doesn't mean anything. It's just this is the function notation. And what this allows me to do is now I can input a variable in here to find an output. All right, and so we use functions a lot more when we start talking about real life data, and we have some fluidity things going on with our functions and so forth. So, but really these mean the same thing. We're just moving on past just this basic slope intercept form. All right, so if I want to evaluate this function, and I might say evaluate f of 3 for the same function. Evaluate. So what this is telling me to do, this is a 3 of x if you can't read it. This is telling you to put a 3 in for x. That's what I put a 3 in right here. So it's saying, it doesn't have anything to do with the problem. It's just telling me what to do. It's saying, all right, substitute a 3 in for x. So let's do that. Put a 3 in right here. And then let's see what we get. So if we put a 3 in right here, we have 9 plus 5 is 14. So f of 3 is 14. And what that really means is when I put a 3 in for x, my y value is 14. It's an ordered pair. That's really what that's all it is. Now let's say I had a graph and I wanted to find, let's see if I can make this graph somewhat decent. How do I want to do this? Let's see. Okay. Let's go with that. All right, so here's a line, a linear line, and I want to know what is f of, let's say, -2. So this is just f of x. I don't know what the equation is for it. This is just giving me the graph, so I don't know the equation. But my question is, okay, so what is f of -2? Well, I know what that is saying. What is the y value when x is -2? So I'm going to go over here. When x is -2, the y value, so when x is -2, I go to my graph. What is the y value of that? Oh, it's -1. Okay. So what would f of 1 be in this graph when you look at it? So f of 1 means I go over 1 on the x-axis, go up to my graph. What is the y value? It's 1. So that's how you can evaluate a function on a graph. Now, sometimes you might evaluate, what if I just said, let's go back to this. Let's say, what if I said, what is A? Evaluate your function at A instead of a number. Well, all I do is put an A in there. And that just means that I'm going to not have just a numerical answer. I'm going to have a variable in my answer, not a big deal. So I just put an A in for whatever the X value is. That's it. So f of A is, and so if I were to write that as an ordered pair, I could. I'm not going to ask you to do that, but I just want you to understand what it's saying. Here's your X, this is your Y value. All right, awesome. So let me ask you one more. Well, that's okay. I'm going to go back up here. I kind of forgot a graph I wanted you to do, even though I've already talked about this. Can I come back up here and just show you one graph? What if I gave you this graph? Let's see here. Let's go here. This graph. And I wanted you to find the domain. Okay, what would the domain of this be? Remember, we're going from here to here. So domain is your X values. So I'm going here, well, that's a -2, but it's an open circle. So that means it's not included. So the domain is going to be a parenthesis because it's an open circle. Starts at -2, and where does it go? To a +2 with a bracket because it's a filled in circle, so that means it's included. All right, what would the range of this be? So the range is their lowest point. Well, what's your lowest point? Lowest point here, and it's a solid line, so what's a bracket? The lowest point is -2. And what's the highest point? Well, here's the highest point of the graph, and what is that on the y-axis? It's a 1. All right, but it's an open circle at 1. So that's going to be 1 with a parenthesis. Okay. And so is that a function? Do a vertical line test? Yes, it's a function. Now these are called continuous graphs because they're continuous because I don't have to pick my pencil up if I trace it. All right, so if I had a graph like this, let me just come down here. If I had a graph like this, say I had something like this, all right, would that be continuous? Well, no, because anywhere I trace that, I have to pick my pencil up, right, to go to the next part. This is called the piecewise function. We're going to talk about that in at the end of the chapter 2, I think. But anyway, so this would not be continuous because I'd have to pick my pencil up. Even if I just had this part of it and maybe my line extended through here, for example, if I did that and I was tracing it, I'd have to stop, pick it up to go over the whole and keep going. So this would also not be a continuous function either. All right, because I have to pick my pencil up. So I just want you to recognize what that is. So just really know that continuous just means it goes on continuously and I can just trace it and I don't have to pick my pencil up. That's a simple way to remember it without getting into really big, higher mathematical terms with it. So, all right, so moving on here, let's see. Let's talk a little bit about, gotta kind of see where I am here. Function. So we kind of talked about what functions are, and we talked about, we talked about function notation. So let's talk about, we talked about evaluating. All right, so we're going to move on to slope. So we're going to talk a little bit about slope now. Okay, and so slope, slope is just a measure of a line's, like how much it rises, the distance that it travels up or down. Kind of, so the y-axis, that's the up or down, divided by the run, right? So it's the rise over the run. And the rise is your y values. And this is your x values. But what it really is it's the difference of each of these. So if I have a line, for example, if I have a vertical line here, right, the y values, it's the difference of the y values over the difference of the x values. So if I look at a picture, and let's say I just have these 2 points right here, all right, so here's my line. So within that line, I'm going to just make this triangle, a right triangle. Now I could make it up on top or I can make it on bottom, it doesn't matter. But this helps me count. So this is your rise, it's your y values, but it's the difference of your y values. So this delta y, we don't see that all the time, but that means change in y. And this means the change in x, and that's what a slope is. And so here's your rise. So how many units is that? 2 units. And here's your run. 1, 2, 3. That's 3 units. So this slope, now the variable that we use for slope is m. All right, so this slope is 2/3. And if your slope is positive, and so if this is going up, increasing from left to right, kind of like you're driving and you go up, that's positive. All right, so here, let's look at this one. Let's say we have this. All right, so let's see if we can figure the slope of that. Now, I will show you this right here is the formal definition, and it's y2 minus y1, or formula, over x2 minus x1. And this is just saying subtract your y's over subtracting your x's. All right, and so if I look at something like this, I'm going to pick 2 points, any 2 points. They just have to be good points. Like, don't pick a point right here because it's right in the center of a square, and I don't know exactly what that measurement is of it, right? I can't find exactly what that point is. So you need to have really good points. So here's a good point where it crosses into the corners of the squares there. Now I'm going to connect those. I can connect it with a right triangle on the top or on the bottom. I'll do this one on the top. I'm just going to go over and come down. So how many units is the rise? 1, 2. The run, 1, 2, 3, 4, 5. All right, now I have to put the positive or negative. So just like you're driving a car, I'm going down this, I'm going downhill, right? I'm going down, it's decreasing. So that means it's a negative, and it's rise over run. All right. Now let's talk about if I have an ordered pair, and that's kind of where this comes into play a little bit more. So if I have an ordered pair such as 4, -7, and 1, -2. You want to find the slope. So the slope on this is going to be, remember this is your x value, this is your y value, x value, y value. Now, if you want to use these subscripts, then this would be y2 and this would be y1. This would be x2, this would be x1. But I'm just going to tell you a hint. As long as I subtract these the same way, it doesn't matter which way I do it. So if I want to take y1 minus y2, that's totally fine. But then I have to take x1 minus x2. And if I go this way, then I have to go this way. All right? So, but just the formal, that's what those would be. So if I use this formula, so the slope is going to be y2, be -2, minus a -7, careful with those negatives, and 1 minus 4. All right, so these two negatives, remember this is saying the opposite of a negative. That's really what that is saying. So an opposite of a negative is a positive. So anytime we have these, it's going to become a positive. Over 1 minus 4, -3. All right, so this becomes a positive 5 over 3, -3. You can use your calculators if you struggle a little bit with that. All right, you're going to be able to use calculators on a test, so you're welcome to use a calculator on that. Now, remember though, I can write this fraction. I just want you to recognize, I could write this. This right here means the same thing as this, means the same thing as this. These all are the same. These all are the same thing. So it doesn't matter where that negative is written. I mean, just so you know that. It's a fraction. So that negative can be shown anywhere on that. All right, let's do another one. Let's say we have, let's try this one. Let's say we have 2, -3, and let's do -5 and 6. Now I'm going to show you the other way I can do it. I'm just going to subtract the other way, but I'm going to do them both the same way. So I'm going to take -3, so m is equal to, I have to move that up here. There we go. So m is equal to, I'm going to go this way this time, and I can do that as long as I go this way with the x values. So -3 minus 6 over 2 minus a -5. I could subtract it either way. I could go this minus this over this minus this, or this minus this over this minus this. But this is our formal way that we do it. You know, if you want to use the y2 minus y1, that's totally fine. You can do that. But just recognize it doesn't matter which way I subtract them as long as I subtract them both the same way. All right, so here then, -3 minus 6 is a -9. Okay, this becomes a positive. So 2 plus 5 is 7. So -9/7. All right, how about this one? Let's go with and 6 -4. Okay, so let's subtract the y's. 2 minus a -4, and then 6 minus 6. So this becomes a positive. 2 plus 4, 6 minus 6 is 0. Well, what happens if you have a 0 in the denominator? We don't have an answer for that. We don't have a definition for it. So this is called undefined. It's undefined when you have a 0 in the denominator. And the slope of an undefined looks like a vertical line. Okay, this is a vertical line if I graph it. If I plot those 2 points and I graph them, it's going to be a vertical line. It's going to look like this on the graph. And that doesn't have a slope, right? It doesn't have a slope. It's straight up and down. So that's why it's undefined. Now, if you work a problem out and you end up with a slope of, let's say, 0/3. Okay, this means your slope is 0. Now that's different. A slope of 0 is going to be like this. And that just means it has no slope. There's no slant to it. So this is okay. That is a slope of 0. But this is undefined. Anytime it's in the denominator, that's undefined. All right, so let's talk about slope-intercept form. Just about done here. So slope-intercept form. So slope-intercept form is written as, you've seen this, I know, in your 980s, if those of you that had 980. So this is y equals mx plus b. And this is usually the equation that we use. But now we're going to start using some different forms of equations we're going to learn in the next section, that because our math gets a little bit more higher level, and so we have to use something more than just y equals mx plus b. But this is just a review. So review, all of this chapter 1 should be mainly a review for you guys. So if I'm given something like y equals -4x plus 1, all right, tell me then what would this, gosh, been working out. So just kidding. All right, so here, what would the slope be? Well, if I compare it here, it's going to be a -4. So my slope is a -4. Well, this is the y-intercept. All right, so m equals slope and b equals the y-intercept. That means where does it go through the y-axis? That's what that means. Well, this is what that is. So this is going to go through the y-axis at 1. So when I write a y-intercept, if I asked you specifically, give me the y-intercept, I would want you to write that because it would be an ordered pair. Would you agree? Where it goes through if it goes through here, the y, that's an ordered pair. So when you're talking about writing an intercept, you need to write it as an ordered pair. Now, if I just said find m and b, you can just do it like that. But if I said, tell me the y-intercept, I want you to write that as an ordered pair because that's what an intercept is, 0, 1. So what about if I have this one? Okay, so here, what would the slope be? Well, it's whatever this coefficient is in front of x. And if there's not a number showing, it's not 0 because it wouldn't be there if it was 0 x's, right? It would be gone. So, and if it were a 2, it would be showing a 2. So if it doesn't show a number, there's always a 1 there that's not showing. So your slope here is 1. And then your b is a -8. Okay, what about this? Y equals 6x. What is your m? Your m is whatever follows the coefficient in front of x. So 6. And what is your y-intercept? Well, there's nothing there, so it's 0. Okay, what about this? Kind of think about what that looks like. So I know what the y, I know the y-intercept. This graph means it's going to go through here where y is 3. It's going to go through that. That's what it's going to look like. It goes through the y-axis at 3. So that means it has a y-intercept of 3, but it doesn't have a slope. Well, it has a slope of 0 because it's not showing a slope, right? It doesn't have any slant. So this, the m would be 0, and your b would be 3. All right, so let's do one last thing, and let's find an equation from a graph. So we're going to find an equation. And I know that you did this in your class before, but some of you may not remember that. That's totally fine. But let's say we have a graph here. Unless you're my students, that you're in my class, and I expect you to remember it. All right, you can't see my face, so that's probably a good thing. All right, so let's go here and here. Kind of work with, this is not going to be the perfect, maybe I better try. Maybe grab a ruler, so I have a ruler here. All right. So here's our line. Somewhat, it's not great, I apologize, to get a ruler next time. So here's our line. So what I want to know is, what is the slope of that line? So I would ask you to tell me the slope. So pick any two good points, right? This is a good point, and this is a good point. Okay, I could have picked this point. Well, I don't see any other good points. Those might be the only ones I could have picked. All right, so we're going to draw the triangle. This is 1 unit. This is 3 units. So it's rise over run. So the slope is equal to 1/3. Now, is it positive or negative? You have to remember to put that on there if you're drawing it from a graph, if you're taking it from a graph. Well, that line is decreasing from left to right. It's going down. So that means it's negative. So its slope is negative 1/3. Okay, so what is the y-intercept? The y-intercept, can you tell me where it goes through the y-axis? Right here. So that is 0, -1. I asked you to write it as an intercept, so that's why you have to write it as an ordered pair. This point is 0, -1. Okay, so what is the equation? Well, we want to do the two things that you have to know in order to get an equation is you have to know the m and you have to know the y-intercept. You have to know the slope and the y-intercept. We know those. So let's put it into our slope-intercept form. Okay, so y is equal to our slope, which is -1/3, x plus b, which is a -1. So that would be the equation. Okay, now, are there any zeros? Are there any zeros? Well, what that is saying is, where does it go through the x-axis? I want to know the zeros. I want to know where it goes through the x-axis. So let's just pretend it goes through right here. So I have a 0 at x equals -4. I don't have any other zeros. That's the only one. Okay. All right, so that is all I have for you for section. I know it was kind of a long one, but that is all I have for you for section 1.1 and 1.2. So I hope you guys have a great day. All right, thanks.